This is a quick recap of what we looked at today on the rectangular hyperbola. So the rectangular hyperbola is one whose asymptotes are perpendicular to each other. So our usual equation, x squared on a squared minus y squared on b squared equals 1, and our normal asymptotes are at y equals plus or minus bx on a. Well, now these asymptotes are perpendicular, so the two gradients, that is b on a multiplied by negative b on a, must equal negative 1, which implies that negative b squared is equal to negative a squared, and that is that b equals a. So if I come back and substitute it back into my original equation, I get as my rectangular hyperbola x squared on a squared minus y squared on a squared equals 1, or in other words, x squared minus y squared equals a squared. And that's the equation of any rectangular hyperbola, such as this. The asymptotes now, because b equals a, are plus or minus x. So this would be y equals x, this would be y equals negative x. Those two at right angles to each other. Passes through that. Okay, so negative a, that'd be a. We can take this a little bit further, and we can in fact discuss the eccentricity. And the eccentricity, we know that b squared equals a squared, e squared minus 1. But as we just said, for a rectangular hyperbola, b squared will be a squared. So in other words, a squared equals a squared, e squared minus 1. Rearranging that gives me e squared equals 2. In other words, e is equal to the square root of 2. So this is the eccentricity for any rectangular hyperbola that's going to hold. So I now have this new couple of set of equations with the asymptotes now y equals plus or minus x, and we need to know these things. Okay, so what I want to do now is, if I look at this line is 45 degrees away from lying on the axis. So what I want to do next is I want to rotate the hyperbola 45 degrees. What that would mean is then my hyperbola will come back to be something that probably looks more familiar from your earlier studies. A hyperbola looks like this. Now today in class we looked at how this rotation takes our hyperbola x squared minus y squared equals a squared and gives us instead xy is equal to a squared on 2 once we rotate it. I'm not going to go into recap that theory today, but that is the equation for this hyperbola. Further, we said that this distance a, which is this distance up here rotated, and we called this point C and C, so we formed this right angled triangle in here, and we could see that 2c squared was equal to a squared by Pythagoras' theorem here. In other words, c squared equals a squared on 2. So that let me rewrite the equation of my hyperbola in this form as xy equals c squared, where that point C lies on the line at 45 degrees, the line y equals x. If I continue that line up here, then my original foci, which is AE, and E being root 2a, 0, will also be rotated 45 degrees, and it will now be up here, the foci will be. Now that distance from O to S will be preserved under rotation, so this distance OS will still be root 2a. So I'll just redraw that there for the foci, and we'll try and find the coordinates of this new foci. And so I'll redraw. I've got O and I've got S, and I've said that's root 2a. I'll make that a right angled triangle to match what would happen over here, and I'll just call these two coordinates, I'll just call the two sides x. Again, Pythagoras' theorem, x squared plus x squared is equal to that squared, so 2x squared is equal to 2a squared. X squared is equal to a squared, in other words, x is equal to a. And so my foci are now at A, and S dash will be at negative A, negative A. So this is A, and down here S dash, negative A, negative A. Finally then the directrices, and again I went through today in class and showed them. In the interest of saving time in this video, I'm not going to go through them, but the directrices here and here, the directrices have also been rotated by 45 degrees. We actually know they're in the form x plus y plus k because they're parallel to the line y equals x, and that k turns out to be x plus y plus or minus a equals 0, and that's the equation of the directrices. So that's a recap of the essential points from this morning that you need to remember and recall.